Math 3, Unit 10, Section 4. Today we're going to be talking about solving trig equations. Before we do, though, I want to go back to our lesson, Section 3, and talk about the few things that we didn't get to. And it's going to play into our lesson today, so hopefully this will help make things more clear. If you read on your papers, it states, identify all the quadrants where the terminating ray for theta can lie so that the equation is true. Hint, there should be at least 2 quadrants identified for each of these. What they're asking for is when is cosine, which we know cosine are the x values, when is x negative? If you look at a coordinate graph, we know this is our x-axis. When you're going on the x-axis, to the right is positive. So right here, cosine is positive in those 2 quadrants because the x values are positive in those 2 quadrants. Cosine is negative in these 2 quadrants because on the x-axis, when you go left, that is negative. Therefore, cosine of theta equals negative 5 over 12. This answer for cosine could be in quadrants 2 or quadrant 3. Those are my 2 answers for that. On this next one, they're talking about sine. We know sine is talking about y. They are asking, when is y going to be positive or negative? Well, y will be positive or negative in every single quadrant, but we're going to go ahead and write this out. Y is going up and down. So up is positive, down is negative. Therefore, sine is positive in quadrants 1 and 2 because on the y-axis, when you go up, it's positive in these 2 quadrants. And sine would be negative in the bottom 2 quadrants because when you go down, the values are negative. For this one, because it's saying plus or minus, positive or negative, the answer is quadrant 1, quadrant 2, quadrant 3, or quadrant 4. If you want to write all 4 quadrants, that's fine too. Tangent. Tangent's a little bit more tricky because tangent is the value of y over x. So here they're asking, when is y over x going to equal a positive value? I'm going to kind of write this one out a little bit different just to hopefully make sense here. We're going to start with the y values since it's y over x. So in this quadrant, y is positive and x is negative. Maybe we want to put y and x because on the y-axis it's positive going up. Oh my goodness, just kidding. If you caught that, you should get a candy. Okay, y is positive and x is positive. So in this quadrant right here, you have a positive over a positive, which makes a positive. In quadrant 2, you're going left and up. So here, y is positive because we're going up, but x, because we're going left, x is negative. And a positive divided by a negative makes a negative. So we can see here that tangent was positive in quadrant 1, but it's negative in quadrant 2. Going down to quadrant 3. In quadrant 3, we're going down on the y. So y is negative, and we're going left on the x-axis, which means that x is negative. But a negative divided by a negative makes a positive. So tangent is positive in quadrant 3. In quadrant 4, when you go down here, y is negative over, and when you go right, x is positive. And a negative divided by a positive is a negative. So the question was, when is tangent positive? Well, tangent is positive in quadrants 1 and quadrant 3. Okay, so we're going to build on this concept today in section 4. So we're going to turn the page now and get back to Unit 10, Section 4. So to start with here, I want us to go ahead and write each of the graphs. So starting with sine, we're going to talk about when is sine or y positive or negative. So in our coordinate plane here, y is positive in quadrants 1 and 2, and it is negative in 3 and 4. And this will be helpful as we're doing our work today. Cosine, which is x in the coordinate plane when we're looking at our x values, x is positive in quadrant 1 and 4, and x is negative in quadrant 2 and 3. Tangent, which we just talked about on the other page, y over x. Okay, so quadrant 1, it's positive, positive, which makes a positive. Y and x are both positive, which makes a positive. In quadrant 2, x is negative and y is positive, and a negative and a positive make a negative. In quadrant 3, x is negative and y is negative, and a negative divided by a negative makes a positive. And lastly, in quadrant 4, you have a positive for x and a negative for y, and a negative and a positive make a negative. And so that's, we know sine, cosine, and tangent are positive and negative based on this information. Next, it asks us to identify all possible quadrants in which the terminating ray for theta could lie. Here it's saying sine of theta is less than 0. What that is saying is y is less than 0, or y is negative. Where is y negative? Where is sine negative? Well, if you look up here, we know that sine is negative in quadrants 3 and 4. Next, tangent is greater than 0. That is saying y over x is greater than 0, okay? Or tangent is positive. Where is tangent positive? If we look up here, we can see tangent is positive in quadrant 1 and quadrant 3. This next one is a little bit tricky. I'm going to kind of talk about it in two different ways. One thing is we have a sine squared here, and so if we were to take the square root of both sides, anytime you take a square root of something, it's going to make it positive or negative. And so this one is really dealing with plus or minus. You could also think about it as if you took sine, which is y, and let's say y is positive, and you square it, you're going to get a positive. Or if y was negative, and then you square it, you are still going to get a positive value. So, therefore, in this, for sine, we're dealing with, you could have a positive sine value or a negative sine value, and when you square them, you will always get a positive value. This is also saying sine squared is greater than 0. Therefore, on this one, it is all 4 quadrants. And if you're confused by this, we'll come back to it again later, okay? So just bear with me here for a few minutes. Okay, cosine squared of theta is less than 0. Now, this one is a little tricky because on this one, it's saying that it's going to end up being a positive value because it's greater than 0. On this one, it's saying it's less than 0, which it would make a negative value. When is cosine going to be less than 0? When is cosine going to be negative? Well, based on what we just talked about here, cosine is dealing with your x values. If you square a positive x value, you're going to get a positive value. If you square a negative x value, you're going to get a positive. It will never equal a negative value. No way. So therefore, this answer is no solution. Because when you square that, it will never end up being a negative value. A positive is never less than 0. Okay, so we have our special right triangles. We dealt with these a lot last week. We are going to be working with them again today. I would like you to mark in these angles. We have our 30 and our 60 and our 90. We are going to be dealing with these in a unit circle, which means that I want 1 for my hypotenuse on each of these triangles, okay? If you need to go back in your notes and figure out how I'm going to get these other sides, please do that. I'm not going to spend time on going through solving the 30, 60, 90 triangles today, but we know that across from the 30 will end up being 1/2 based on 30 being an A value in our solving that we did previously. Across from our 60 is √3/2. On our 45, 45, 90 triangle, across from each of the 45s, if this is 1, when you rationalize the denominator, you end up getting √2/2 for both of the 45-degree sides. And then over here, this is when you have a 60-degree triangle down here and a 30 up here. Across from the 60 is √3/2, and across from the 30 is 1/2. So these triangles are going to help us a lot today. You also, if you don't have it yet, I would like everybody to get this unit circle passed out. It says fill in the unit circle. There is these pieces of paper here, and I'll give a chance to get those passed out if you don't already have them, and we will talk about that in a minute. So here it says, solve for all values of theta such that 0 degrees is less than or equal to theta is less than or equal to 360 degrees. So what they're saying is they don't want any values of anything that's greater than 360 degrees. We're just going to deal with one unit circle, okay? The first thing you have to do on these is solve for sine. So in order to solve for sine, we're going to first add 3 to both sides. When I do that, I get 4 sine squared of theta equals 3. We want to get sine squared of theta by itself, so next I'm going to divide by 4 to both sides. These eliminate. I have sine squared theta equals 3/4. The next thing we're going to do, because this is sine squared of theta, is we are going to take the square root of both sides. So I'm taking the square root of everything. Whenever you're making a square root, your answer is going to be plus or minus, okay? So sine squared theta equals plus or minus the square root of 3 over, and what is the square root of 4? 2. And this was not sine squared anymore. The square root of sine squared is just sine. Okay, no more square. So sine of theta is either plus or minus √3/2. And you don't need the plus or minus on both the top or the bottom, okay? You just need one plus or minus. So this is saying, when could sine be positive or negative? Which quadrants? Okay, so to start with here, we know that sine could be positive in all 4 quadrants, okay? But they want to know the specific degrees on these. And so we know that our answer is going to be in all 4 quadrants. So there are going to be 4 different answers that we're going to end up giving. This is where filling in our unit circle is going to be helpful. And so we're going to go out and we're going to take a little side note here to fill this in. So all we're going to fill in today are the degrees. So on this unit circle, when we fill in the degrees, the first one I would fill in here is 0. We know that's 0. Up here, we know this is 90. Over here is 180. Down here is 270. And when you come back up here, this is also 360 degrees. So hopefully that part is pretty easy. The next thing I want to do is our 45-degree angles. And so there is a 45-degree angle in this first section here. And the 45 is in the middle because you know we have a 30 and we have a 60 and 45 would be in the middle. And then what I like to do to find out where the 45s are in the other quadrants, because what happens is we know that over here there's going to be a 30, a 45, and a 60, but those aren't their actual degrees. So we need to figure out what their actual degrees are when you're in this quadrant. Well, how you do that, and we're going to start with the 45-degree angle, is we just add 45 degrees to it. So when you add 45 and 45 together, you get 90. which makes sense. And then we want to add another 45 degrees, which puts us right here, and this is 135 degrees. When you add 45 again, it should get us to the 180 spot, which it does. We add 45 again, and we get to the 225 degree mark. When I add 45 again, I should get to 270, which I do. We add 45 more, which will put us here in the middle, which is 315. And then when you add 45 one more time, it gets us back to the 360. So we got all the middle 45s in each of these quadrants. Next, we're going to go to the 30. So as we go around, every time you add 30, you get to the next angle, which is not a 45. But so if you have 0 plus 30, we get 30. And then if you add 30 plus 30, you get 60. And if you add 60 plus 30, you get 90. And so on the next one, 90 plus 30 gives me 120. And then we add another 30, and we get 150. We add another 30, and we get 180. We add another 30, and we get to our 210. We add another 30, and we get 240 degrees. You add another 30, and you get 270. Over here, we add another 30. We get 300. Add 30, we get 330, and add 30, and we get 360. Okay, so we're going to go back to our problem now. And here it's saying, when is sine root 3 over 2? When is the y value root 3 over 2? If you're looking at each of these, think of these almost as being like coordinate planes, okay? And so on this one, this is like where the x is root 3 over 2, and this is where the y is root 3 over 2. Here is your x, here is your y. Here is your x, here is your y. So where is y, or what degree is y root 3 over 2? And you can see right here that y is root 3 over 2 when it is 60 degrees. 60 degrees gives you root 3 over 2. So in quadrant 1, here's 60 degrees. This is where sine is going to be root 3 over 2. So one of my answers is 60 degrees. Now we know that you can have this value of y in all 4 quadrants based on it can be positive or negative root 3 over 2. So where would be the 60 degrees in the second quadrant? So see how the 60 degrees is up here at the top? You know, it's the third line up. So over here, the third line up is 120 degrees. So the next one is 120 degrees. Same thing here. This one right here is our 30. This is my 45. So 60 degrees in quadrant 3 is 240 degrees. And then lastly, in this one, my 60 degree, so this is 30, 45, and this would be 60, would be the 300 degrees. And so these are the answers that you're looking for. These are the answers, the values for theta between 0 and 360 degrees, where sine is going to give you the value of root 3 over 2. Okay, next problem. So here we have to first solve for cosine. We add 5 to both sides. This eliminates. 10 cosine theta equals 5. In order to get cosine by itself, we're going to divide both sides by 10. These eliminate. We have cosine of theta equals, and we're going to reduce 5 over 10. And 5 over 10 reduces to be 1/2. Okay, we know that cosine is dealing with our x values. Okay, so first of all, which quadrants is x going to be positive? And if we look back up here, cosine will be positive in quadrant 1 and quadrant 4. So my answers are going to be from quadrant 1 and quadrant 4. The next thing we want to think about is when is cosine or x 1/2? So if you look here, when is cosine or x 1/2? And there it is. This is where x is 1/2. And it's across from which degree? 30. Good. So we're looking for the 30 degrees in quadrant 1 and quadrant 4. Well, quadrant 1 is easy because the 30 degrees in quadrant 1 is just 30 degrees. In quadrant 4, if you look here, the 30 degree from our x-axis is 330 degrees. This is our 30-degree angle. Here, this one is our 45, this is our 60. So right here, so the two values that theta could be to give us this value is 30 and then 330 degrees. Okay, let's move on to the next one. So here we have tangent squared of theta minus 6 equals 2. We're going to add 6 to both sides. 2 tangent squared of theta equals 6. We're going to divide by 2 to both sides. Tangent squared of theta equals 3. Next, we need to get rid of our tangent squared, so we're going to take the square root of both sides. Anytime I take a square root, anytime you make a square root, it's going to be plus or minus. So this is going to be plus or minus root 3. Okay, so again, tangent is our y value over our x value. Because this is plus or minus, we know it's going to be, there's going to be a value in all 4 quadrants. Okay, so now we have to figure out when is the value of y over x going to give you root 3. You can also think of this as like root 3 over 1. Also remember that you are only looking at the numerators, because remember how everything has the same denominator and you would, the denominators would end up canceling out. So we're looking for when is the y value root 3 and the x value 1. So going up here and only looking at our numerators, okay, so I'm just going to highlight kind of the numerators here for us. We are looking for when is the y root 3 and the x 1. So if you look here, y root 3, x 1, this is dealing with your 60-degree angle. The opposite is y over the x is 1, 60-degree angle. That means the first one is 60 degrees, and it's going to be the 60-degree angle in all 4 quadrants. Well, we actually already found the 60-degree in all 4 quadrants because it was right back here. So it's going to end up being the same answer, but just to look at our unit circle here one more time. So it's always 60 degrees from the x-axis. So this is 60 degrees from the x-axis. This is 60 degrees from the x-axis is the 120. 60 degrees from the x-axis down is the 240. 60 degrees from the x-axis here, 300. Okay, so 60 degrees, 120 degrees, 240 degrees, and 300 degrees. That is when tangent will be positive or negative root 3 over 1. This next one, they've actually factored this for you. There will be a time when you get to factor these, which will be fun. But for right now, it's already been factored, and so you just have basically 2 problems on 1 problem. So we would set each of these equal to 0 and solve them, starting with root 2 cosine theta plus 1 equals 0. And then we have 2 sine theta minus 1 equals 0. I'm going to make this a little bigger here for a minute. Sorry if some of you haven't been able to see as well. Okay, here I'm going to subtract 1 to both sides. Root 2 cosine theta equals negative 1. Then we divide both sides by root 2. And so I have cosine theta equals negative 1 over root 2, but we need to rationalize our denominator. We multiply by root 2 to both the top and the bottom. That makes a pair of 2's, so we end up with cosine theta equals negative root 2 over 2. if we go ahead and finish this one, we're looking for when is x negative. So first of all, and I'm going to go ahead and write my cosine function right here. So when is x negative? Well, x is negative when it goes left. So my two answers are going to be in quadrant 2 and quadrant 3. And specifically, I'm looking for when is x negative root 2 over 2. And if you look here, this is where x is root 2 over 2 is a 45-degree angle. Okay, and so we're going to look for the 45-degree angles in quadrant 2 and 3. So if you take your unit circle, in quadrant 2, the 45-degree angle is 135 degrees. And in quadrant 3, the 45-degree angle is 225 degrees. Those are my answers, 135 degrees, 225 degrees. Next problem here, we have our sine. Add 1 to both sides, add 1. 2 sine theta equals 1. Divide by 2 to both sides. We get sine of theta equals 1/2. So we're looking for when is sine y, when is it positive 1/2. If we're talking about the quadrants for sine, and I'm going to write it here for you, when is y positive? So y is positive going up. So we're looking for quadrant 1 and quadrant 2. Now, when is y 1/2? This is where our special right triangles come into play. Where is y 1/2? So if you look here, here is y. Y is 1/2. That is the 30-degree angle. 30 degrees, y is 1/2. So we already have one of our answers then. Quadrant 1 here, 30 degrees is where sine is 1/2. And then in quadrant 2, we need to find the 30-degree angle. And if we look here in quadrant 2, the 30-degree angle is right here. You're talking about your reference angle to the x-axis, and that's 150 degrees. And so for this problem, it's actually all 4 of those because we were dealing with that. Okay, we're going to go ahead and turn the page. Do just a couple more problems here. Make sure you get it. Again, we need to get our trig function by itself. I'm going to subtract 2 root 3 to both sides. These eliminate. 6 tangent theta equals negative 2 root 3. We divide by 6 to both sides. I get tangent of theta equals negative 2 root 3 over 6. You would want to reduce. 2 and 6 can reduce and make that a 3. So we're actually looking for negative root 3 over 3. If you'll notice and think about back to previous problems, when I had an answer like this where I had a root 3 and a 3, I had to undo the rationalizing in order to figure out where they were. And so for tangent, because we're dealing with y over x, if you were to go back and look at all of our special right triangles here, there is never a value where we have a root 3 and a 3 in the numerators. We have a root 3 and we have 1s and we have root 2s, but we don't have a root 3 and a 3 in our numerators. And so that should be a clue that you need to basically unrationalize this denominator. And so we're going to unrationalize it by multiplying by root 3 to both the top and the bottom. We end up with tangent of theta equals negative 3 over, sorry, what am I doing here? Multiplying by root 3 to both the top and the bottom. We end up with negative 3 over 3 root 3. These reduce, and so my final answer is negative 1 over root 3. Okay, tangent negative. Where is tangent negative? In this quadrant, y and x are both positive. Over here, y is positive, x is negative. So this is tangent's negative here. Down here, x is negative and y is negative, and 2 negatives make a positive. And in quadrant 4, x is positive, y is negative. So tangent is negative in quadrants 2 and quadrant 4. So we're looking for answers that will end up being in quadrant 2 and 4. But we need to figure out where is y1 and x root 3. If we go back to our triangles on the other page, where is y1 and x root 3? And so you can see right here, y is 1, x is root 3. This then is a 30-degree triangle, okay? The y value over the x, okay? 30 degree is for quadrant 1. But we're looking for the 30 degree not in quadrant 1, but in quadrants 2 and 4. So if we go back to our unit circle, 30 degrees in quadrant 2 is 150, and 30 degrees in quadrant 4 is 330 degrees. 150 degrees, 330 degrees. Okay, last one of these problems. Get sine by itself. We subtract root 2 to both sides. 2 sine theta equals negative root 2. Divide by 2 to both sides. These eliminate. Sine of theta equals negative root 2 over 2. When is sine negative? So if we think about sine, and sine as being y, where is y negative? Well, y is negative when you go down. So the two quadrants that we want the values are going to be in quadrant 3 and quadrant 4. So now we need to figure out what degrees we're dealing with in quadrant 3 and 4. So if we go back, negative root 2 over 2, where is y negative root 2 over 2, or just root 2 over 2? And y is root 2 over 2, 45-degree angle. So we are looking for the 45-degree angles in quadrant 3 and quadrant 4. The 45-degree angle in quadrant 3, and your 45-degree angles are always the one in the middle. So we're looking at 225 degrees. Remember the 45 from here to here up to the x-axis, that's your 45-degree angle. We're talking about reference angles. But the actual degree is 225. So 225 degrees. And then the 45-degree in quadrant 4 is 315 degrees. So sine is negative root 2 over 2 at 225 degrees and 315 degrees. And those are your two answers. Okay, this last one, they are asking us to find the perimeter and the area of this isosceles triangle. They also have told us that cosine C is 12 over 13. Based on that, we know that cosine is adjacent over hypotenuse, which is 12 over 13. So if we were to draw our line here, we know that 48, half of 48 is 24, so each of these sides are 24. Now, on here, it is saying cosine of C is adjacent, they said 12, but here they're saying 24. So what's happening is you have to think about these, and this even goes back to last unit. These are proportionals. They probably wrote a fraction here and then reduced it. And so to get this actual length, because here it was reduced, because 12 and 24 don't match, what would you do to 12 in order to get 24? Okay, you would multiply by 2. So therefore, for the hypotenuse, we have to multiply 13 by 2, which makes 26. So adjacent over hypotenuse, so 24 over 26. So that works out. And if this is 26, then we know this is 26, which works out great. So for perimeter, all we do is add all the sides. And so if you add 26 plus 26 plus 24 plus 24, add those all together, and you should get 100 units for the perimeter. Awesome. Okay, area. Area is base times height divided by 2. Well, my base, I already have it, which is 48, times my height, and this is your height. Your height always makes a 90-degree angle. I do not know what my height is. What will I do to find my height? Hopefully you said use the Pythagorean theorem. So we have a squared plus b squared equals c squared. 24 squared plus x squared equals 26 squared. 24 squared is 576 plus x squared equals 26 squared is 676. Subtract 576 to both sides. We get x squared equals 100. We take the square root of both sides and x equals 10. Therefore, my height is 10. Now I can finish this. 48 times 10 divided by 2. 480 divided by 2 equals 240, and that would be units squared because we're dealing with area. All right, and that is it for today.